with the final talk. So our next and final speaker will be Dawid, based in Stockholm, and we'll be giving a talk called Separating Realism from Ontology.
Thank you very much. Thanks for the invitation, and thanks for the excellent workshop. The talk I will be giving here is not entirely unknown to a number of the people, I'm afraid, but I inserted 2 new slides, so you have something to look forward to. Yes, it is about separating realism from ontology, and it's joint work with Guy Franzmann from SU and Nordica. And it is about the question how one can be a realist about string theory. Realism canonically asserts that well-established, well-confirmed theories tend to be approximately true. Scientific objects posited by those theories then tend to refer to something in the external world. So that's one of the canonical views of scientific realism. So scientific realism, as understood already at this point, that can be mentioned, is linked to an endorsement of the ontology that is posited by the given scientific theory. Now, of course, string theory is not a well-confirmed theory, so there may be very different views on whether one should, whether it makes any sense to discuss whether or not one can be a realist about the theory. The question here will not be whether one should, but the question would be if one has or at some stage will have reasons to have realist commitment, what would that amount to? How can one be a realist about it? Now, it is by now a time-honored question in the context of string theory how that can work, given that string theory has this web of dualities. So there are those dualities that relate to each other, theories that on a conventional account of ontology look entirely different. So the question is, what does one subscribe to if one has realist commitment to that theory, given that those dual representations of the theory make so fundamentally different statements about basically everything one would want to assign ontological commitment to. And there has been a number of authors who, in one way or the other, have proposed the following. Some of them are listed here. If one searches for what is real about theories with dualities and string theory in particular, one should focus on the common core that is shared by all those dual theories. So the ontology attributable to the common core provides a natural basis, maybe a starting point, maybe a basis for realist commitment. Now, a slightly different question that has been mentioned already by Sebastian in his talk as well is the question of physical equivalence. So James Reed and Müller-Nielsen wrote a paper where they discuss historical cases, for example, Newtonian theory of gravitation, and they come to the conclusion that it makes sense to endorse what they call a motivational approach to physical equivalence. So they argue that empirical equivalence per se is not sufficient for declaring two theoretical concepts, different representations of the same physical theory. That means, on their definition, physically equivalent. And they argue that what is needed in addition is the specification of a common core. And that, of course, if one subscribes to that, gives a task to the philosopher of string theory, which is the task to find that common ontology in order to be able to say that string theory, that the various dual versions of string theory even represent different representations of the same theory. Now, Sebastian and Jeremy Butfield, in their book, endorse that motivational approach. So they think that's a fair claim. However, they then present a view on ontology that they argue allows for the specification of a common core ontology in all cases of duality relations. So in a way, they say, okay, yes, we need that ontology, but it is, in a way, nearly by definition, the case that we can provide that in the case of string duality, in the case of dualities. Therefore, it does not narrow down the set of duality-related representations that can be called one theory, compared to a perspective that does not have that requirement of a common ontology. So what they do, and I can be very brief about that because Sebastian already said something about that. What they do is they define string dualities in terms of a common core. They say that a duality between two physical theories requires that the two theories share a common core. And the common core then is itself a theory, the common core, what they call a common core theory. So this guarantees that duals are physically equivalent on Reed and Melanison's account if the common core theory has an ontology at all, and if you don't have any further conditions on what is a common core ontology, you can be fairly confident that you find one. That common core ontology may be then fairly thin, but Sebastian and Jeremy argue it can be enriched by what they call augmentation, which in my crude description amounts to kind of lending from the dual in very specific ways, as long as this does not lead to contradictory commitments. Therefore, they argue, they have a response to Reed and Moller-Nielsen, and they also have argued that string theory can provide a satisfactory basis of scientific realism. So that's their response. The way that works in context of their system is based on defining a theory as this triple that Sebastian has already mentioned, triples of quantities Q, state S, and dynamics B. And that triple then is shared by the models of the theory, and the models of the theory, they have extra structure that reaches beyond that triple, and that would be the basis for specific ontological commitment that is associated with an individual model of that kind. Models for them are the various dual representations of the theory in their language. Therefore, any set of empirically equivalent models that can be represented by a triple can allow for a common ontology. And this means that string dualities do establish one theory, and they can provide a basis for realist commitment. Now, what I want to do in the following is I want to propose a quite different take on that issue. And I want to propose that based on a different understanding of what we want to achieve when we spell out realist commitment for a theory. I will say a little more about that in a minute. At this point, I just want to mention that the view we propose will provide a view on the question of scientific realism in the case of string dualities. And we will argue that this perspective is in line with the novel aspects of the situation in string theory. But it is also helpful, we think, for understanding the issue of realism in the context of quantum mechanics, more specifically in the context of the selection of a tensor product structure in quantum mechanics, where it's kind of related issues with respect to realist commitment arise. There is also the question, given that the selection one may be much more straightforward and much more aligned with a straightforward understanding of the situation, but there is nothing, that seems nothing metaphysical about choosing that rather than something else. So there is something slightly comparable issue with respect to scientific realism. And we argue that these kinds of issues more generally can be addressed by our proposal. However, since this is a workshop on string theory, I will entirely focus on the string theory case. Now, there are two guiding principles that provide the basis for our way of thinking about this. The first point is that string theory is in many ways a quite novel type of theory, or kind of set of theoretical statements. And if one tries to develop a philosophical analysis of this, we argue that should mostly focus on understanding those specifics, on understanding the specifics on their own account, without being preconditioned by what happened before. So by an older, more traditional previous understanding of what a scientific theory amounts to. So that will be one goal. So it will be focused more on that than on the aim to defend continuity in philosophical conceptualization with previous cases. However, that does not mean that continuity is not important or cannot be helpful. And in particular, we think that continuities should be accounted for, and they are very important, where they are required for understanding the way in which the new theory retains the character of a scientific theory. So once it comes to this core issue, okay, is this still a scientific theory? Then the continuity is crucial, because then one wants to relate what is happening here to what has happened before in science. So the idea is to bridge those two issues and to understand realist commitment along those lines. Now, if one applies that just as a first rough perspective to the status of string dualities on our understanding, it is our understanding that for physicists, empirical equivalence is sufficient for acknowledging physical equivalence. There is not much about the need to find a common ontology to be found in the discussion of those issues. The question is whether one can establish empirical equivalence. That's what the tests of duality relation and so on are about. The second point is, however, if one makes one step backwards and views string theory, it is important for string theorists and for any physicist actually that string theory is a scientific theory in the sense that it is in principle empirically predictive. So there is something the theory predicts, and that is more than just let's say applying a scheme to the data in the sense of data mining. So even though at this point this may seem very difficult, that's what the theory has to be about if it can call it, if it qualifies as a scientific theory. Now, this predictive character of the theory, or the requirement that the theory has such predictive character, directly links to one main motivation for scientific realism, which is the canonical, fairly old, one may say by now, main argument in favor of scientific realism, the no miracles argument. And the no miracles argument works that the following way. It observes that scientific theories are predictively very successful, and it argues that this remarkable record of predictive success can only be explained by the hypothesis that string theory relates to something in the real world. So there is a lot of debate about that, whether to what extent that argument works, but that's not the topic today. The point is that this is a crucial argument. So there is a crucial argument that directly links scientific realism to the issue of prediction. Therefore, on that account, in order to merit realist commitment, the theory also must have empirical predictive significance. Otherwise, this entire argument would fall flat from the start. Now, one way, and the way we figured was most effective for representing this characteristic of a theory in general terms, as a precondition for meriting realist commitment in principle, is Dennett's idea of framing theories as compression mechanism, which Dennett proposed in a paper in 1992. So what he says is that a scientific theory, in order to merit that name, needs to represent data sets in terms of substantially fewer bits of information. In this sense, the compression mechanism. So now, if one links this view to scientific realism, the no miracles argument would be based on the observation that a given theory is a successful compression mechanism. Therefore, if we want to be realists about string theory in particular, we should be realists about the theory in a sense, or by framing the theory in a way that does represent the theory as a compression mechanism. Therefore, the question is whether, or the first question, let's say, is whether a common core theory, or more specifically, the definition of a theory as a triple, satisfies this condition. Now, I won't have a full answer to that question, but I have some thoughts about it that will guide our further reasoning. String theory is, as already said, a fairly specific kind of theory. It does not know, or one does not know at this point, a full formulation of a theory. There is no known specification of a Lagrangian of the full theory of equations of motion, but the basis of the full theory. The starting point for the formulation of a calculable theory is the perturbative expansion in terms of interacting strings. So the level 1 in mathematical representation. Now, the duality relations connect types of string theory and thereby they establish them as empirically equivalent representations of the theory, and thereby they are means of reaching out beyond the model's perturbative regime. And on our account, this reaching out beyond the perturbative regime invites what I would call a prospective perspective on string theory. So in order to be realist, the understanding would be, in order to be realist about string theory, one needs to point at something I can be realist about. And that, once again, I mean, I think this Marcus schema is very helpful for spelling that out. One points at something one expects to be a level 3 theory, even though one doesn't know it. So the idea is that there is an unequivocal way what is known about the theory points at some full-fledged theory. And if I'm a realist, a scientific realist, I'm a realist about that. And I'm also a realist, most importantly, about the full evolution or the dynamics or whatever of that full-fledged theory. Which means that all the dynamics that ends up, for example, in whatever way, and whether that will ever be understood or in whatever way it happens, that ends up selecting a ground state of the theory that can then be associated with dynamics we can in principle measure. So the idea, therefore, is that in order to link the theory, so the idea is that on one hand, I need to be realist about the full theory in order to link the full theory to predictions, or even in order to spell out the theory at the current point. We need to spell out those perturbative expansions plus what we know in addition about this. So we need to spell out the various types of string theory, among which, and even going beyond string theory, maybe dual quantum field theory representations, everything that we can reach at this point, and that gives us information about what the theory will be like. Now, on that basis, it is fair to say we think that there is no foundation, no basis for viewing a common core of those dual representations as a compression mechanism. One needs to rely on the models, and one needs to rely on the entire web of models in a sense, in order to do that. In order to make string theory a compression mechanism, which means that if I want to be realist about the theory, I need to be realist. It's kind of a holistic way about the theory that is pointed at by those perturbative descriptions, etc. But I need also I need to use those perturbative expressions approaches in order to do that. So it is a thoroughly non-motivational view of what is the same theory. So it is in a way exactly the opposite view to Reed and Moller-Nielsen, who say, in order to say that's the same theory, we need first to establish that there is a common ontology. On that view, that's just not the case. The idea is that there is this kind of massive amount of circumstantial evidence that there is a full theory, and that already establishes or can establish let's say a high confidence that a theory of that kind exists. And then we can discuss it. We can discuss how confident one can be, whatever. So it's not a foregone conclusion, but that's what the debate is about. And that also what the debate is about once I enter the step of being or not being realist, or thinking or not thinking, that the theory as it stands already can be formulated as something I can in principle be realist about. Now, there is another thought. I mean, in a way, I have mentioned that now already. That makes it plausible that one should include all those dual representations in what one has realist commitment about. And that is the understanding that this web of duality itself is a characteristic of the theory. And it's an important characteristic, first because it moving from one dual to the other is an important element of figuring out, let's say, quantitative implications of the theory or structural characteristics of the theory. But more specifically, because the duality structure determines the theory's classical limits, and even more specifically, it determines that the theory has solutions that are near to more than one classical limit. So the web of duality spells out those classical limits. Therefore, at this level, at the level of realist commitment, the duality structure itself seems to be a crucial characteristic of the theory that itself deserves realist commitment. On that view, it is plausible to say that realist commitment should be to a theory that serves as a compression mechanism and represents or implies the duality structure. And this leads to this holistic perspective on the theory that merits realist commitment. So what, of course, that means is that ontology, it's not clear what role ontology can play in this, right? Because ontology didn't appear anywhere so far when spelling out realist commitment. So the question is, what is the real ontology on such a view? And the proposal is that there is no real ontology of the fundamental theory. It is not helpful to look for one. It doesn't amount to denying that once the full theory has been fully understood, one may come up with something that resembles that. But it seems that looking for an ontology at this point is not in line with the core role played by ontologies. And the core role played by ontologies, we argue, is to specify an observer's perspective. So unlike the realist commitment that, as spelled out, is about the full structure of the theory before the theory has even reached a ground state that allows to spell out an observer's perspective, the ontology characterizes on this account an observer's perspective by specifying the link towards the ontologized low energy classical world that we live in. But it doesn't mean that it is the classical ontology, of course, but it means that there is a continuity from that to that classical ontology. Therefore, in order to spell out that role, and in order to acknowledge that ontology does play an important role, ontology must be separated from fundamental realist commitment. And to be a little more specific about that, I want to think about a little bit about those neoclassical limits. So generally, dualities lead in some sense, once they are quantum at all, they lead from neoclassical to deep quantum. In the case of S duality, that's entirely straightforward, from weak coupling to a strong coupling. In the case of T duality, it leads from a situation where there is a large extra dimension, so we have nice localization, and the neoclassical spectrum of momenta in the transversal dimension to a situation of where on a small radius, that's not the case anymore. The spectrum is far apart, there is no localization at all. In the ADS-CFT case, it leads from a situation, small curvature, to strongly coupled on the CFT side, and vice versa. So there is something of that kind going on as well. Which means that in all those cases, one identifies a specific neoclassical limit that the theory allows for. And of course, the theory allows for that only if there is a solution that is close to that limit. So if there is the assumption that there is a very large landscape of solutions, the expectation would be that some of the solutions are close to each of those neoclassical limits. And in those neoclassical limits, the individual duals that represent that in the best way, let's say perturbatively, those are the ones most adequate for making calculations close to that limit. So the idea would be that if I start with some theory in some representation, and I have a solution that is near a classical limit, then a duality transformation would lead me towards a different theory that is in a deep quantum situation. And in order to reach the neoclassical limit of that theory, I then need to change the solution of the theory towards a solution that is close to that neoclassical limit. So then I have two different worlds, so to say, possible worlds or in multiverse realized worlds that play out, that can be represented based on one of those individual types of theory. I mean, of course, it may not be as simple in general. There may be mixtures where some complexes are better represented in one way or others in another, but the idea would be like that. So therefore, this identification of web of dualities plays an important role, or plays the crucial role for specifying the neoclassical limits of the theory. And the idea would be that each of the neoclassical theories then has a natural ontology associated with it. And that's the natural ontology of the type of theory that is in a perturbative regime, close to that limit. So in other words, we can, let's say, if we could fully spell out our parameter values of standard model physics in terms precisely of one string theory solution, we might expect that if we are sufficiently precise, we can on that basis specify which type of string theory can be linked to that. Therefore, we can link the low energy ontology of our standard model perspective to an ontology of the corresponding type of string theory. That would in principle be the idea. Right, I think I've said most of that already. Maybe one thing one needs to emphasize at this point is that, of course, if I move within such a string theory from the perturbative regime, where the perturbative description gives me an empirically quite accurate picture of what's going on, and if I move towards a strong coupling regime, the meaningfulness of the corresponding ontology becomes highly questionable, and in a way dissipates. So if I go to a highly quantum regime, or let's say I move on to a situation that has a dual description that is neoclassical and that has an entirely different ontology, clinging to that initial ontology is rather unhelpful. So that's, of course, in line with the statement that ontologies are about this observer's perspective, and the observer will always be close to, or the observer's experiment, let's say, will always be close to some classical limit. Now, therefore, if we spell out the ontology of a type of string theory near its classical limits, we understand that we get a statement about gauge structure, spectrum of elementary objects, brain structure, and so on, only in that limit as a relevant statement about the world. So it's only a statement about the observer perspective, and not about the full theory that includes many other solutions that cannot be adequately characterized that way. Now, one important aspect of this view is the way this is linked towards the power of effective theories. So so far we have moved back and forth among neoclassical and then deep quantum limits at the level, let's say, close to the Planck scale. And now we want to move towards lower energies and think about effective theories that represent the situation. So we start up there with supergravity theories, so to say, probably, and then go down all the way to the standard model. Now, somewhere there, the dualities will be broken. So if we look at the effective theories below, they won't have the spectrum of several neoclassical limit anymore. There will be one neoclassical limit associated with those theories. Therefore, from the low energy perspective, the idea to link ontology to scientific realist commitment is much more plausible. It is not necessary, and it may not always be the most helpful perspective on the situation, and that would then, if we would talk about it, lead over, for example, to the situation in quantum mechanics. But I could do it. There is not the problem of inconsistency due to the inconsistent ontologies of the individual theories that describe the neoclassical limits. So therefore, at the level of effective theories, if I'm an effective realist, for example, about those theories, I can be an effective realist and still endorse the connection between ontological commitment and scientific realist commitment. This works, and that's the reason why, if Reed and Melanesian look at historical cases and say, look, they always tried to find and succeeded in finding the common ontology, the reason is, yes, because they were down there, right? They were at an effective level where this worked. But once you go to the Planck scale, once to go to a situation where string dualities are important, this breaks down. So it is a characteristic of the fundamental theory at high energies that this doesn't work anymore. So let me therefore just spell out the proposal. The proposal is to separate ontology from realist commitment. And ontology is about the way our observational perspective of an observer's perspective is linked to the theory. Therefore, spelling out the ontology on that definition of ontology starts from an observer's perspective. And the ontology is linked to a specific neoclassical image. The ontology we are committed to depends on the neoclassical image we happen to be in. So this is an observer-based ontology. On the other hand, realism is about the commitment to the theory's approximate truth. So spelling out the real theory does not start from observation, but merely needs to explain observation. It states based on, of course, it will be related, it will be based on our observations, but once we made the statement of realist commitment, we have dropped that aspect. We have said, for reasons so and so, we now think that this is an approximately true theory. And endorsing this claim amounts to endorsing the entire theory, not from an observer's perspective, but in an observer-independent way. And this is necessary because we want to explain how the situation where an observer is placed at some close to some of the neoclassical limits actually came about. So we need that observer independence in order to use the full power of the fundamental theory. Therefore, realism neither selects one dual, nor on our view reduces to a common core, but it takes the full theory as being specified by the individual models as its basis for realist commitment. Therefore, it does not at all insist on any real topologies. And on that basis, it spells out, or it points at an observer-independent reality. Thank you.
Thank you very much. More discussion, please.
Thank you very much. This is very interesting, but there's something that I find deeply puzzling and sort of incongruent about the perspective. A realist is a realist about the scientific theory. The theory is a compression mechanism of data, which to my mind means ineliminably must factor in an observer's perspective. But then the realism is about something that doesn't include the observer, but it just somehow gets the observer independent reality there. Wouldn't it be more commensurate with a Dennettian point of view of what theories are to say that realism encompasses more? It doesn't select the dual, it doesn't reduce to a common core. It is a commitment to the entire structure, but including the way all the different models connect to classical limits and ultimately to observers. You see what I mean? Would that be more like
I think so. Yes, you're absolutely right about that. And I should have emphasized that more clearly. Or I didn't emphasize it at all, actually. That our perspective takes this Dennettian idea of a compression mechanism as a starting point. It's not a Dennettian point of perspective. It's not a Dennettian idea, the entire thing. It does not at all. It differs in many respects from what he says. The reason why we think it is so important in that particular case to detach realist commitment from the observer's perspective is that the observer's perspective is no starting point for the theory, simply. It is not even a possible starting point, right? It is if you understand string theory as a theory that one way or the other generates a landscape of ground states, and we happen to be in one of them. And the theory, however, we expect from the theory once fully spelled out that it explains how we reach there. But the process of getting there is not a process that we observe. We are not outside the system, right? We are still there at this one in this one ground state, but we want to understand the mechanism. Therefore, if once we understand that the ontology is very helpful for getting that perspective, but it runs into problems once one leaves that perspective and enters the observer-independent framework, let's say, our conclusion is, okay, let's drop ontology when we talk about the fundamental theory. Maybe to say a little more about, I didn't say anything next to anything about what kind of realism that is, right? One rough thought about this would be that if one thinks about this system of the phenomenal surface, if you want, of an underlying ontology and of a structural characteristic of being a reduction compression mechanism. Let's say the canonical picture would be that both of those are happening, right? There is the contraction mechanism and there is this reductive path towards behavior of fundamental objects or whatever. It's not entirely clear per se that this is the case. One might say that if I spell out the theory structurally, there is no meaningful way of separating what about the theory I reify and what about the theory I don't reify. So to say, there is no meaningful difference anymore between parameters and the core message of the theory. However, it still serves as a compression mechanism. And I'm not saying that it's clear that in string theory that is the case, but I'm saying it's not clear either that it's not the case. And so, and that's the first step. The second step is, and there is a way of having realist commitment to the theory nevertheless, even without assuming that this is the case. So that, in a way, that's a different way of framing the core idea.
Yeah, thanks for the very. Sorry?
Yes, go ahead.
Yeah. Thanks for the very challenging talk. I have actually an objection, and the objection not comes from looking at something different from string theory, which is just QCD. So you look at QCD. QCD also has a very different weak and strong coupling limit. The strong coupling limit of QCD is the world of pions, protons, and neutrons, and the weak coupling limit is the world of quarks and gluons. But according to your construction, if I understand correctly, you would say that the ontology of the model described by protons and gluons, protons and neutrons and pions, would be that ontology, and then there would be a different ontology for the weak coupling limit in which you have quarks and gluons. Now this is very counterintuitive because everybody would say that protons and neutrons are made up of quarks and gluons, right? So your approach to string theory, if you use it in QCD, will give us somewhat counterintuitive statements about what we mean by the construction of reality. I think it would be maybe a different approach. I wouldn't say that the ontology should be attached to semi-classical limits. I think ontology should be related to consistent mathematical approaches. And we know that the theory of protons, a theory of protons and neutrons, I mean, for example, chiral perturbation theory, or is a theory of pions, for example, is not completely consistent. It's non-renormalizable. It has, even problems at the level of renormalizability. So I would say that an ontology based on a non-renormalizable theory is going to be deficient in a sense. So there is a way in which you can compare different ontological perspectives from your point of view. So I would say that the actual ontology of protons and neutrons is quarks and gluons, and this is why QCD, this is in a sense the ontological discovery of QCD, that the low energy worlds of protons and neutrons is actually ontologically worlds of quarks and gluons, right? But this doesn't fit with the pattern ontology as a semi-classical limit. So I would attach more ontology to a consistent mathematical description than to a semi-classical limit. Also, I appreciate a lot the idea that different semi-classical limits give different interpretative pictures more than, but I would call them more interpretative pictures than ontology.
Yes.
Maybe it's a question of terminology. But I think ontology, also another problem is I think an ontology based on semi-classical limits is too much dependent on the accidental fact that we are humans. Semi-classical limits are human artifacts. Right? And when I think what is in a sense interesting about the ontology of science, the ontology implied by modern science, that it gives us ontological statements beyond our human abilities. When we say that the world is made of quarks and gluons, we're making an ontological statement that doesn't depend on our accidental choice or accidental fact that we live at these energy scales, right? That we are low energy beings, right?
Yeah.
And that I think is interesting that ontology is not completely attached to that. I mean, it's a common sense for scientists in which, protons are made of quarks, right? And this is an ontological statement. Like most of scientists would say, if they were explaining what ontology is, they would say that this is an ontological statement. And I'm worried about the fact that your perspective doesn't really lead directly to this.
Yeah, yeah. I mean, that's a very good point. And part of it, I think part of my response would reach beyond what I was talking about here. It would reach towards, so to give a first answer, I would make a significant distinction between changing energy levels and changing the effective theories in a way, and attributing an ontology to an effective theory on the one hand, and reaching a situation where you have very various semi-classical limits of a fundamental theory. And I agree that once we discuss the former, so once we discuss this hierarchy of energy scales, there is a way of making sense of the hierarchy of ontologies one gets from those individual theories. So for example, if I have an ontology about the Standard Model, and I have ontology about I don't know, some type of string theory close to the Planck scale, those will also be different ontologies quite significantly. They are in a fairly straightforward way related to each other by changing the energy scale. Now once one enters the issue of QCD and talks about about high energy perspective on quarks, and the low energy perspective where we don't discern quarks, but we just talk about nucleons, for example. That is less straightforward, but the framework still works. So there is a meaningful way of telling that story and saying that if I look at this more fundamentally, then actually the quarks are the fundamental objects. In the same way in which if I look at the quarks more precisely at higher energies, I will observe their extendedness as perturbative strings. So this story can be told, and I think it is a valuable and important story because it tells something highly instructive about our reach towards testing smaller distances and understanding more fundamental structure of the world. And of course, this would further down go all the way towards ontologic commitment to tables, which I can't have at this very crude level. And I don't deny thereby that they're atoms, right? So I think that story is important and it has to be retained. I completely agree, but it is a different story from this situation of various semi-classical limits, some of which are just limits where we don't live, right? So it's not it doesn't make sense to say from that fundamental perspective that quarks are the fundamental particles if we know that there are other neoclassical limits of the theory. And let's assume we endorse a multiverse perspective on the world. And we say there are other edges, other corners in this multiverse where there are no quarks. So it's not, it is, they have other fundamental particles. And it makes sense from their perspective to say that those are their fundamental particles in exactly the same way as it makes sense for us to say that quarks are. So there is something more dramatic going on once one moves towards this spectrum of low energy limits. So that's the idea. And maybe one thing to add might be that even there, this is not as, so to say, a dogmatic verdict. It is maybe some better understanding of string theory reveals something else that emphasizes the significance of an ontology at that fundamental level in a different way, and therefore makes it, even from our perspective, let's say, more natural to talk about some kind of ontology of fundamental string theory. So it's in a way, the main message is not that there should not be ever an ontology of fundamental string theory, but the main message is that it is helpful to separate the two conceptions, conception of realist commitment and the conception of ontology. And the main example where this becomes conspicuous is this example of spectrum of low energy limits.
So, Alex, you had a question? No, you didn't. Okay, Sebastian.
Yeah, so about the use of the concepts, especially the common core and also the motivationalism. So Butterfield and I make a distinction between an augmented common core and a reduced common core. So it seems to me that what you're talking about is more like the augmented common core, where you put different dual models in one structure. But then the reference, I mean, the connection with the motivationalism, it's less clear to me, because what Wiedemann and Nielsen talk about is, so the question there is, when do we have theoretically equivalence models? And what they argue is that you first need to be able to work out a common ontology in order for you to consider those ontologies as being the same. But what you are saying is that the ontologies are different. So I don't see the connection. So there is a connection. So for the reduced common core, yeah, that's standard motivationalist discussion. But for the augmented common core, I mean, one might have a discussion about whether the ontologies are the same. So I think that is a question that is still valid there. But the specific observer-dependent ontology that I don't see how that goes together with the idea of theoretical equivalence or physical equivalence.
Yes, I must say that once I try to compare your approach of your use of limitation with respect to the common core with our approach, I still don't have a full understanding. How it seems to me that there are significant differences. It seems to me that so what I'm not clear about is let's say the cogency of selecting an augmented common core. So I mean, but that goes quite a lot into the details of this. So it seems to me that in some contexts, the way you play out augmentation plays out in your book seems to amount to using to having, let's say, some kind of conditional ontology, talking about let's say in the case of T-duality, about wrapped strings in some contexts, but not in others. So that might be related to what we are doing. On the other hand, once you emphasize, for example, that M theory might, for some reasons, have a preferable ontology to the 10-dimensional ontologies of the 10-dimensional string theories, that would be quite clearly not in line with what we say. So I'm still, I mean, I think I'm still not entirely clear about the comparison.
Yeah. But I mean, so you introduce motivationalism as part of saying that these theories are theoretical equivalent, but basically the discussion you're having is theoretical inequivalence, it seems to me, because the ontologies are different.
Yeah, that's what we deny, actually. I mean, we say we don't agree with their definition of physical equivalence. On our view, it is unhelpful at the fundamental level to make that distinction between empirical equivalence and physical equivalence. That's in a way the main claim. So the main claim is that while their perspective comes from canonical scientific theories where you can argue that, if you just think about string theory, it is not the natural way to characterize the situation. That's in a sense what we
Yeah, I mean, what I don't see is how one can have physical inequivalence with different ontologies, but I guess your definition of physical equivalence is just different.
and definition of ontology.
So it's not really disagreeing with them, but using different words.
I think it's disagreeing.
I'm really sorry, we are out of time, but maybe we can continue the discussion. So join me in thanking Richard one more time. And the plan is
The
now.
plan is to go for drinks and then we're gonna have dinner at 7:30
Perfect.
at Café de Tiop.
Are you sure about that? Because there's incoherent information.
No, the program has been updated. Annika
Okay.
promised she updated it.
Okay.
But it's at 7:30, that I'm sure.
Yes.
I like consistency.
And before you leave, just one last thing. Baptiste had to leave, but on his behalf, and on behalf of everyone else, I think I would like to thank Enrico for organizing this wonderful workshop.